Okay, so again, we have a Norman window. So a Norman window is like this. It's a rectangle surmounted by a semicircle. They're telling you that the total perimeter is 15 meters. Okay, so the question is, which dimensions should I do my window so that it lets the maximum amount of light is admitted, basically, so that the area of this shape is the greatest. Okay, that's all it is. All right, so let's start labeling stuff. So I'm going to call this here X. So obviously this would be 2X. And this I'm going to call Y. Okay, so what's given to me? So let me just move up here because you have the question. So what is given is that the perimeter is 15 meters. Okay, so I need the perimeter of this shape. Okay, which is pretty easy. So the perimeter will be 2x plus y plus y. So 2x plus 2y plus the area here of the semicircle. What's the area of a circle? It's 2 pi times the radius. But since we have a semicircle, it's just pi times the radius. So it's going to be pi times the radius, which is x. And that has to equal to 15. Who's got a question with this setup?
Sir, can we do the problem with like I did the bottom, I put it as X, and then like the radius I just put it like half of X.
So
can we do the problem like that?
No, I don't want, because I'm going to end up with fractions that I don't want. It's right, the answer is going to be right, but I don't want to use a more complicated way to do it.
Okay.
Okay, so it's better this way. Okay, but what you did should be right as well. Okay. Okay, so now I'm going to isolate the y here.
Yes, sir. I have a question.
Uh-huh.
Why did we use the area of a semicircle instead of the perimeter of a semicircle?
This is the perimeter, it's not the area.
Okay.
Right, the perimeter is 2 pi radius. 2 times pi times the radius divided by 2, because it's a semicircle. Is that okay?
Yes, yes.
So now y is what? Y is going to be 15 minus 2x minus pi x, and all this divided by 2. All right, so now we want to, this is what's given. So now let's see, what do we want to maximize? The area. And what's the area here? It's the area of the rectangle, which is 2xy, plus half of the area of the semicircle. So half of the area of the circle, I mean, so it's pi times radius square, which is the area of the circle, divided by 2. This is what I want to maximize. Okay, are you all with me? Okay, let's keep going. So now what do I do? Tell me, what do I do now?
You replace y
by this. Very good. Okay, so A will be 2 times x times y, but y is this expression, so 15 minus 2x minus pi x over 2, and then plus pi x2 over 2. Okay, I could cross all the 2's. And so I have, if I distribute the x, so 15x minus 2x2 minus pi x2 plus pi x2 over 2. This is my function for the area. I'm going to combine the x2's together. So I have 15x minus, and I will have 2 plus pi over 2 times x2. Okay, so this is what happens if I simplify this expression. Any questions? Just one thing, I think I made a mistake. No, it's fine, perfect. Okay, so let's I will continue here. What do we do next? Right, we find the derivative. Very good. So a prime is 15 minus the derivative of x2 is 2x. So 2x times this number, 2 plus pi over 2. Okay, and if I simplify this, well, so I get basically a prime, we're just going to continue here, is equal to 15 minus x times, and this will be 4 plus pi. Okay, I just distributed the 2 inside. Okay, so again, what is the interval? So x is what? Between what and what? So what is the smallest possible value of x? It's 0. And what's the maximum value of x?
Infinity.
Is it infinity? I have a perimeter of 15, it can't be infinity. Okay, so if y is 0, okay, if y is 0, then what's x? X will be 15 over 2 plus pi. This is the maximum possible value that x could take. If you have x anything bigger than this, you will have a perimeter that's bigger than 15. Okay, so how do I get this? By letting y equals to 0. Okay, in here, y equals to 0. Factor out an x, 15 over 2 plus pi. Okay, so a prime equals to 0 means what? It means that 15 minus x times 4 plus pi is equal to 0, and therefore if you isolate x, you will get 15 over 4 plus pi. Well, that's pretty much what we have here.
But sir, how can the y be 0?
How can what? I'm sorry.
How can the y be 0?
How could the y be 0?
Yeah.
Well, if it's closed, if I close this, close this, close this, if it's like this, imagine I make it like this. very small. The y is very small. So I could exaggerate even more. You understand?
Okay. Yeah.
Well, actually, it's not like this. It would be more. It would be more like this. Okay, but okay. Still a semicircle. Okay. So I need now to evaluate the area. The area, what is the area is right here. Add the three values. So a of 0, a of 15 over 4 plus pi, and then a of 15 over 2 plus pi. And then I need to calculate which one is the highest value and which one is the lowest value. And that's I'm going to get my answer this way. Okay, so if I plug in 0 here, of course, I get an area of 0. If I plug in this here into here, so what do I get? So I need to calculate. My calculator. So it's just that I'm running out of space here, but I'll do it on a separate paper. Sorry. There you go. More or less. Okay, so so let's start with this one of 15 over 4 plus pi is equal to, so 15 times 15 over 4 plus pi minus 2 plus pi over 2 times 15 over 4 plus pi squared. So I get 225 over 4 plus pi minus, so I will do 4 plus pi over 2 times 225 over 4 plus pi squared. Okay, I'm just doing some basic algebra. And then I'll multiply by 2 here. So 2 times 225 minus 225 over 2 times 4 plus pi. And so I get 225 over 2 times 4 plus pi. This is what I get here. Okay, and then I will do the same thing with 15 over 2 plus pi. Let's do it. I have to move up the paper, I think, but let me just write it at least. Okay. Fifteen over 2 plus pi minus 2 times 2 plus pi over 2 times 15 over 2 plus pi squared. 225 over 2 plus pi minus, so this will be one second, why is this 2 here? No, there's no 2 here. Sorry, there's no 2 here. Okay, so 2 plus pi over 2 times 225 over 2 plus pi squared. Okay, whatever that value is. Okay, I don't know, should I calculate it? 225 over 2 plus 5 pi times, this is 4 plus pi over 2 times 225 over 2 plus pi squared. Okay, so I need the common denominator, so I will multiply here by 2 times 2 plus pi, and as well here 2 times 2 plus pi. Okay, it's just simple algebra, but it's long.
Sir, I think someone's in the waiting room trying to get in.
Thank you. Okay, so here I have 450 times 2 plus pi minus 225 times 4 plus pi, and all this over 2 times 2 plus pi squared. Okay, so 450 times 2 is 900, 825 times 4 is 900, so this disappears. 450 pi minus 225 pi, I get 225 pi over 2 times 2 plus pi squared. This is what I get. Right here. Okay, so I get that this is the maximum. 225 divided by 2 divided by, it's about 15.8, and here $13. So this is the maximum. Get it? Right, forget all the calculations here, the long thing, it's annoying and it's easy, but the idea is solving here. Okay, so I see 0, then goes up to this value, then it goes back down to this value, so this is the maximum. Okay, so I need the dimensions, so let's find out what y is. So x is 15 over 4 plus pi, and so y is, if you plug in x into here, you will get the y. Okay, so the y should give you 15 over 4 plus pi. I'm going to let you do the calculations. That's it, and then that's going to give you the answer to the, that's the y, and of course the x is just the radius, so 2x will be 30 times. Question?
Sir, I have a question on
Yeah.
how you factored on the first page.
Yes.
Under the, when you're trying to maximize the function, how do you go from the second to last line to the final area.
From here to here?
Yeah.
Okay, so what I did here, I did minus pi x2 plus pi over 2x2. This will give you minus pi over 2, right? It's minus 1 plus a half is minus a half. And then I pull out a minus. Okay, so minus 2 x2 minus a half pi x2.
Okay, thank you.
Okay.
Sir, can we put the real values? Like instead of pi, can you put the real numbers?
Yeah, the real numbers. I prefer the pi like this, but yeah, you could put the real numbers. Okay, any questions? Okay. So let's do, we need more, right? More problems? Let me give you one from the worksheet that I just posted. Okay, so here it is. Okay, so this is number 7 from the worksheet. So a fisherman is in a rowboat on a lake and 3 kilometers from the shore. So is on a rowboat on a lake and 3 kilometers from the shore. Okay, he wishes to reach a store. Located 2 kilometers down the straight shore. Okay, so he can row at 5 kilometers per hour and run at 13 kilometers per hour. Okay, let's give it to us. So question is, to what point downshore should he row, I guess? Should he row, yeah? Should he row to get to the store as quickly as possible? So here's a situation. There is a lake. Okay, so it's something like this. Do it right like here. Okay, so this is the shore. and this is the lake. And now he's located 3 kilometers away from the lake. So he's about here. This is 3 kilometers straight 90 degrees from the lake. Okay, and the store, of course, is 2 kilometers down shore. So right here, down the straight shore here, this is the store. I'm going to call it, I don't know, store S, point S for store. Okay, so far so good. So this is, of course, 2 kilometers. The question is, oops. Okay. You know how fast he could row, and you know how fast he could run. So of course, if he rows all the way from here straight, well, he's traveling the smallest distance, but he's going much slower because it just goes, he just goes at 5. And if he rows here and then runs, okay, so of course he's going to run fast here and he's going to row slow here on a short distance, but he's traveling a much longer distance. So there must be a point somewhere here. I don't know where. Okay, just 1 second. About somewhere here, I don't know where it would be optimal for him so that he reaches in the smallest amount of time. Okay, so I'm going to call this point P, the point P, and the question is, where is that point? Okay, so is it here, is it here, is it here, is it there, where? Good?
Yes, thank you.
Okay, this is the question. Okay, so let's first call this, this is what we're looking for, right? How far from the store does he have to hit the shore? So I'm going to call this X. And so this will be what? How much is this?
2 minus X.
Very good. 2 minus X. So this is okay. So what do I want to minimize? Okay, so I'm going to write what we want to minimize. We want to get there as quickly as possible. So we want to minimize the time. Okay, so first thing I'm going to do is I'm going to find the distance here. From here to here, what is the distance? And from here to here, of course, it's X. So let's find the distance here. So distance, we have to do Pythagoras theorem. So this squared plus this squared, square root. So 2 minus X squared plus 9 square root, that's the distance. Okay with this? This is the distance. And what is the velocity here? Well, he's rowing at 5. So 5 kilometers per hour. And so what is the time? How do you find the time? D divided by D, right? Square root of 2 minus X squared plus 9, and all this divided by 5. This is the time, we're going to call this T1, the time to get from its starting point until point P on the shore. Okay, and for this part here, what is the time for this part? So the distance is x, the velocity now is 13, and so T2, the time from here to here, the time that it takes him to run, is d over v, so x over 13. Any questions so far? Okay, so now we want to minimize time, so time t, which is going to be T1, which is the time that it takes to row, plus T2, which is the time that it takes to run. And so T will be square root of 2 minus x squared plus 9 over 5 plus x over 13. This is what I want to minimize. Did you get this? Anybody got this? Okay, this is probably the hardest part of the problem. Okay, setting up your equations. Okay, that's where everybody has trouble with math, is when you have to translate a word problem into mathematical expressions, and that's the biggest challenge. Okay, that's why this part of the course I'm taking my time, because this is where I find students have the most trouble. Okay, this and the next in 2 chapters we're going to do related rates, same idea. Okay, after that the rest is easy. Okay. So let's go. I just need to know what x is on what to, from what to what. X is, so what are the possible values of x? What's the smallest value of x? Can you tell me?
0.
Yeah, 0. Okay, so if x is 0 means I'm just rowing all the way to the store. Okay. Or what's the biggest possible value of x?
2.
2, perfect, right? Because at 2 means x is 2 means I'm rowing straight to the shore and then I'm running. Okay, so I need to basically minimize this function on this interval. So now it becomes a regular problem like we did before. Okay, so let's do the derivative. So t prime equals. Okay, so I'm assuming that you guys are okay with derivatives, so I'm going to go a bit faster here. So it's the derivative of the square root is 1 over 2 times. So 5 times 2 times the square root. 2 minus x squared plus 9 times the derivative of the inside, which is 2 times 2 minus x times minus 1 plus the derivative of x over 13 is 1 over 13. This is the derivative, and this has to equal to 0. Okay, so I'm going to let you at home slowly, you can rewatch the video or look at the notes, and I'm going to let you do the derivative on your own. Okay, you should be able to do this step. Okay, so I'm going to clean this up. And so t prime will be equal to x minus 2 over 5 times the square root of this whole thing. Plus 1 over 13 is equal to 0. Okay, let's go. Let's solve the algebra here. So I'm going to send this on the other side. X minus 2 over 5 root 2 minus x squared plus 9 equals negative 1 over 13. This cross equals this cross. Move up a bit. 13 times x minus 2 equals negative 5 times the root 2 minus x squared plus 9. Okay, how do I get rid of the square root? Anyone?
The square both.
Multiply both sides by the square root.
No, if I multiply both sides by the square root, then the square root will appear here. So I need to square both sides. Okay, I'm going to put both sides to the power of 2. Okay, so 169 x minus 2 squared equals 25 times 2 minus x squared plus 9. Okay, so 169 x minus 2 squared equals 25 times, well, x minus 2 squared and 2 minus x squared is the same thing, right? Because it's squared anyway, so the sign doesn't change anything. So same thing, plus 9 times 25 is 175. No, it's 225, sorry. Questions? I'll continue here, see if I could fit the whole problem in this page. Send this on the left, so 169 minus 25, I think it's 144. Yep, so 144 x minus 2 squared equals 225. And then if I square root everything now, 12 times x minus 2 equals to 15, plus or minus. And so x minus 2 is equal to minus 12 plus or minus 15. And so, sorry, over 12, sorry. Okay, and so x is equal to 2 plus or minus 15 over 12 is, if you divide by 3, you get 5 over 4, which is 1.25. So these are the values of x, okay, which is either 3.25 or 0.75. Okay, so I'll let you solve again on your own, redo this algebra here, okay? And of course, this I have to reject because you know that x cannot exceed 2, right? I'm not going to go, well, I'm going to go back to my picture here. 3.125 means I'm going all the way back here, right? That's not good. And so this should be the x. Let me get some more paper. Okay, so I got 0.175, 0.75. And so now I need to check the value of t at 0.75, at 0, and at 2. Right? And see which one is the biggest and which one is the smallest, and I'm looking for the smallest. So let's see. So t of 0 equals what? T of 0.75 equals what? And then t of 2 equals what? So t of 0, I'm going to use it into the function for t. square root of, so 2 minus x, so 0 squared, plus 9 over 5, plus 0 over 13. And so I get 9 plus 4 is 13, so root 13 over 5. Okay, at 0.75, what do I get? So let me calculate this. So 0.72 hours. That's the time that it takes it. If he goes, if x is 0, means that means if he rows straight to the store. Okay, 0.75 means he goes until point P. Okay, at 0.75 from the store. So square root of 2 minus 0.75 squared plus 9 over 5 plus x, which is 0.75 over 13. Okay, so let's calculate this. 1.25 squared plus 9 equals square root divided by 5 plus 0.75 divided by 13. So 0.77, whatever, 70.08 about hours. Okay, so for now, he's the fastest. And when, let's see, when it's 2, square root of 2 minus x is 2, like this, over 5 plus, and x is 2, so 2 over 13. So 3 over 5 plus 2 over 13, so 0.75 hours. And so as you see, this is the minimum. Okay, so let me just draw it again. So it will go to 0.75 kilometers from the store. That's the fastest way to get. Okay, if he goes just a bit before, it's going to take him more time, or just a bit after, it's going to take him more time. Okay, so I'm going to write down the answer. He should row to the point on the shore that is 0.75 kilometers from the store. Are there any questions?
I have a question. Is it okay if we approximated 0.75?
This one here?
No, the first up one.
What?
The second one.
This one here?
Yeah, I approximated the t to be 1, and I got 0.71.
Oh, it's okay.
0.71
Yeah,
hours.
it's okay. 0.71 instead of 0.708, it's fine.